and welcome back to StatLab. Today we're going to continue our discussion on hypothesis testing, but today we're going to look at two proportions. Just as last time, a hypothesis test is used to test a claim with sample data. And just a quick reminder that our null hypothesis means that our test results are true, and HA, of course, is our alternative hypothesis, which is what we are testing. So for two proportions, you're going to have a null hypothesis which states that your P1 is equal to your P2, where last time we had P equal to a number. Now we don't care what the number is, we only care about whether these two proportions are equal or not. And our HA is that they're going to be less than, greater than, or not equal to each other. So as before, we still have to define parameters, only this time we have two. Same as before, for the population of all, let P1 be the proportion. For the population of all, let P2 be the proportion, and fill in the blanks with your context. So today, Sasha is going to continue her investigation of another favorite Canadian snack, ketchup chips, and specifically whether the proportion that like them is different in Atlantic Canada versus the rest of Canada. So in the previous video, Sasha randomly selected 200 Canadian adults and found 122 of them said they enjoy ketchup chips. Now she randomly selects 150 Atlantic Canadian adults and finds 108 like ketchup chips. So let's make sure our assumptions and conditions are met. First thing we'll start with is our independence assumption randomization condition. So this condition is met because she randomly selected the samples from the population of all Canadian adults and the population of all Atlantic Canadian adults. And for our success/failure condition, for our first sample, we had 122 successes, 78 failures. For the second sample, we had 108 successes, and we had 42 failures. Now, notice this time, I didn't do N times P. I took our actual successes and failures, and that's because I wasn't given a P this time. I'm not looking to match up with a specific proportion. I'm merely looking at two sample proportions. So in this case, I don't have a P to multiply by my sample, so I simply use my successes and my failures directly. Now, this condition is met because both successes and both failures are greater than 10. So the first thing that we're going to need to do is calculate our sample proportions. P hat 1 is going to be our 122 over 200, which gives us a proportion of 0.61, and our P hat 2 is going to be our 108 over 150, which is going to give us 0.72. So now that we have our two sample proportions, we can calculate a test statistic. Now this formula looks a little bit messy, and oftentimes in first year intro stats, they might not actually make you calculate this. They might give you the equation and then ask you to fill in the values. But here is the equation with all the values filled in, and in this case, I did do the calculation. And we come out with a test statistic of minus 2.19. So now we have our test statistic. Sasha wants to know if the proportion of Atlantic Canadians that like ketchup chips differs from the proportion of Canadians that like ketchup chips. State the hypothesis and define the parameters in context. So our HO is simply that P1 is going to equal P2, and our HA is going to be that P1 is not equal to P2. So notice I didn't ask if one was less than the other or more than the other. I just asked if they were different, which is why I am doing a not equals to. So we must define the both parameters. So for the population of all Canadian adults, let P1 be the proportion that like ketchup chips. And for the population of all Atlantic Canadian adults, let P2 be the proportion that like ketchup chips. So now we have this test statistic of minus 2.19. We can bring up our Z table and go to our row for minus 2.1 and our column for 9, and we are going to find a p-value of 0.0143. Okay, so we have this p-value now, but I want to point out that we were not looking for a less than or a greater than. We were looking for a not equals to, which means we're not specifying whether it's the bottom end or the top end. So we want the tail, so we need to multiply this value by 2 because we're saying it could be above or it could be below. So if we multiply this by 2, we're actually going to have a p-value of 0.0286. Okay, so that's going to be our p-value. And we're going to test our hypothesis that P1 is not equal to P2. We had this chart last time where we went over whether or not you have significance, which table to use, and depending on your p-value, you will decide on whether to conclude, not conclude, or whether you have a certain level of evidence. In our case, we're given a 5% significance level, and we have a p-value of 0.0286. So our p-value is less than our 5% alpha. So we are going to reject HO and conclude HA. So let's go ahead and state our conclusion in the context of the question. Since the assumptions hold, at the 5% significance level, with our p-value being 0.0286, we can conclude that for the population of all Atlantic Canadian adults, the proportion that like ketchup chips is different than the proportion of all Canadian adults who like ketchup chips. So it sounds like a bit of a mouthful, but it's important. I haven't stated anything in this answer that doesn't need to be here. Every single thing needs to be here. The assumptions hold has to be there. The significance level has to be there. Whether or not you conclude has to be there. And the populations, both populations, have to be there. So we concluded at the 5% significance level. Now, would you expect to find 0 in a 95% confidence interval? It's very important to understand the connection between significance and a confidence level. I mentioned this in the last video, but whatever a 5% significant test says, the 95% confidence interval must agree with it. So since we concluded at the 5% significance level that there was a difference, the 95% confidence interval could not contain 0, because that would mean that 0 difference is a possible answer, and we've concluded that it's not a possible answer. Now, Sasha went ahead and she calculated the 95% confidence interval, which she found to be minus 0.209 to minus 0.11. Interpret the interval in the context of the question. So let's give the interpretation. Since the assumptions hold, we are 95% confident that for the population of all Canadian adults, the proportion that like ketchup chips will be between 1.1% and 20.9% lower than for the population of all Atlantic Canadian adults who like ketchup chips. Now, one thing I want to point out here is notice I did not use the negatives in my sentence. I used the word lower. So don't actually put the negative sign in there. Simply use the word lower or higher to describe whether it's positive or negative. And when you are switching something from a negative value into a positive value, you'll notice that I had to switch the order in which I stated them. In your conclusion, you always want to say the lower number first and the higher number second. Now, of course, in a negative form, it's the other way around, but as soon as I make those positive values, I have to switch them around. So I hope this helped make two proportions make a little bit more sense. And again, just like the hypothesis test with one proportion, it all comes down to very specific wording, and that's where students lose most of their points. So hopefully this video helped. If you liked it, go ahead and hit like, and if you want to see more videos like this, hit subscribe. And in our next video, we're going to talk about the different types of sampling methods as well as experimental design. See you in the next video.